So, GPUs. This is one of those tech words that sounds way more intimidating than it actually is. Like it feels like you're supposed to already know something before you even ask about it. But honestly, once it clicks, it's kind of obvious. Okay, let's start very normal. Imagine your computer is a person doing homework. The CPU is like the brain. It's really good at thinking deep about one thing at a time. Math problem, cool. Decision, cool. Logic, that's his thing. Now imagine the same person is told, hey, draw 1 million tiny dots on a piece of paper right now. This is where the CPU starts sweating. This is where the GPU comes in. The GPU is like having 1000 tiny hands, each one not very smart on its own, but all of them working together at the same time. Each hand draws a dot, nobody is thinking too hard, they are just doing the same simple task over and over but together. That's basically a GPU. Originally, GPUs were built for graphics, like literally drawing pixels on your screen. Your screen is just millions of tiny squares. Every single one needs a color, every single frame, every second. If the CPU tried to handle all that alone, your computer will feel like it's moving through mud. So GPU said, alright, give me all the tiny repetitive stuff. And that's why games need GPUs. Not because games are smart, but because games are busy. Lighting, shadows, textures, movement, all happening at the same time. Now here's where people usually get confused. They hear GPUs are for AI, crypto, video editing, simulations, and they think, wait, I thought GPUs were made for graphics. Yeah, the same thought, but the trick is this. GPUs aren't good at graphics, they're good at doing many simple things at once. Graphics just happen to be the first big use case. AI, that's just a huge amount of math happening in parallel. Video rendering is the same operation applied to millions of pixels. Crypto mining, same calculations repeated endlessly. Scientific simulations, lots of small calculations all at the same time. Same pattern, different job. It's like realizing the machine you bought to make toast is actually just really good at applying heat evenly, so now use it for other stuff too. Another thing people wonder is, why can't the CPU just do all of this? It technically can, but it will be like using one very smart worker to move an entire warehouse box by box. The GPU is more like hiring 5,000 average workers and saying, everyone pick one box. No deep thinking, just movement. This also explains why GPUs have tons of cores, their own memory, VRAM, and consume a lot of power. They are not designed to be elegant thinkers, they are designed to be brutally efficient at scale, which is why a GPU fan sounds like a jet engine when you open a heavy game or render a video. It's not struggling mentally, it's just busy. Now, quick clarification that quietly trips us up. A GPU is not always a graphics card. Your phone has a GPU, your laptop CPU might have a GPU built into it. The big chunky thing people call as GPU in PCs is actually a graphics card which contains the GPU chip, VRAM, cooling, power delivery, and vibes, RGB apparently. Integrated GPU is equals to small, efficient, and good enough. Dedicated GPU is powerful, expensive, loud, sometimes dramatic. And no, a better GPU does not automatically make your computer fast at everything. Opening Chrome tabs is a CPU thing. Typing documents, CPU thing. Gaming, 3D work, AI stuff, and rendering. That's where the GPU shines. That's why some people buy monster GPUs and still feel underwhelmed. Wrong tool for the job. So if I had to say it in the simplest way possible, a GPU is a processor that trades intelligence for numbers. It's not clever, it's just very good at teamwork. And once you see it like that, all the hype around GPUs suddenly makes sense.